Hello my dear students. So I am going to continue the lesson Properties of Matter. In the previous chapters, we discussed what discontinuous nature of matter or particulate nature of matter is. So you all know all matter is made up of constituent particles with spaces among them. So based on how these particles are arranged in matter, they can exist in different physical states. What are they? The solids, liquids and gases. So after that, we discussed how the properties change with these physical states or why they exist in physical states in relation to the particulate nature. So you all have a very good understanding. If we take the solids, the particles are closely packed, they are arranged in an orderly manner, there is strong attraction between the particles. So because of that, they cannot move freely, they can only vibrate, and due to that, they have a definite shape and definite volume. But if we take the liquids, the liquid particles are somewhat far apart. They are not arranged in an orderly manner. So therefore, there is somewhat randomness there. There is distance between particles compared to solids. Therefore, the particles can move somewhat freely. So because of that, liquids have a definite volume, but they don't have a definite shape. They take the shape of the part of the container they occupy. But if you take the gases, the particles are randomly arranged and they can move independently and randomly. Because of that, the interaction between the particles is very, very less, and therefore they don't have a definite shape, they don't have a definite volume. They occupy the full volume of the container and they take up the shape of the container. So that is how the three physical states, solids, liquids and gases, vary due to their particulate nature. So now in this lesson, we are trying to understand how we can utilize physical properties of matter. So utilizing physical properties of matter. So because of this particulate nature, they have different physical properties. So any substance has physical and chemical properties. In this section, in this lesson, we are going to discuss the physical properties only. So before we understand the physical properties, we will try to understand what pure substances and non-pure substances are. So to understand pure substances and non-pure substances, we will consider the following examples. The first example, a cylinder containing nitrogen gas and a cylinder containing ordinary air. Now, if we consider this example, now let's say there's a cylinder containing nitrogen gas and a cylinder containing air. Now, when we say nitrogen gas, it is only nitrogen gas constituent particles. The nitrogen gas particles are the constituent particles. So here we will only have nitrogen gas particles. Only one type of constituents. This type is known as pure substance. Whereas if you take air, in air there is nitrogen. So we have nitrogen. Then we have oxygen. We have oxygen. We also have carbon dioxide. Carbon dioxide. And there is water vapor. And there are other particles as well, other gases. So there can be other components and water vapor also. So water vapor, and other gases. These are in very small percentage. So that's why the small dots. So there is nitrogen, there is oxygen, there is carbon dioxide. Now if you look at the constituent particles of air, there are more than one constituent particle. So then we call that non-pure substances. If there is only one type of constituent particles, pure substances. If there are more than one type of constituent particles, non-pure substances. You have to remember, students, you can't call them impure substances. That is a different concept. So here, pure substances, non-pure substances. So this gas, only nitrogen is pure substance and air is non-pure substance. Only one constituent, more than one constituent. That is one example. So here, if we consider the following, a cylinder containing nitrogen gas and a cylinder containing ordinary air, nitrogen gas is a pure substance, whereas the ordinary air is a non-pure substance. Then we have another example, potable water and pure water. Potable water, pure water. We will consider that as well. Now, what is potable water? Potable water. We have potable water. Normally the water that we get in water bottles, we have those water bottles, potable water. In that, you will have water molecules. So these are water molecules or water particles, let's say. And also, we will have other minerals dissolved in it. Minerals dissolved. So in potable water, you all know, normally water, pure water should not have a taste or an odor. But potable water, there is a slight taste because there are minerals dissolved in it. So what is this? There are water particles, there are mineral particles. So then, is it pure? No. It is a non-pure substance. So here, potable water is non-pure substance. So then, if we take pure water, they have said potable water and pure water. Another name given, we can call it distilled water. We will be using this term. Pure water, distilled water, all are only water. So if we look at, if we consider a bottle with pure water, there is only water particles. Only water particles. So this has only one type of constituent particles. So then, what is that? It is a, what is it? A pure substance. So pure water or distilled water, in the previous example nitrogen gas, they all contain only one type of constituent particles. Here only water particles, in the previous one there is only nitrogen gas particles. But in the non-pure substances, you will find more than one particles or two or more constituent particles. So based on that, we can classify substances as pure substances and non-pure substances. I am sure you all can understand that, students. So with that understanding, I will move on to the next slide. Here we have an assignment where we try to understand where the substances are pure substances or non-pure substances. So this is what we need to do. Pay your attention to the substances given in table 4.3. So here you can see this is table 4.3. It's given in your textbook. Find out about the components in those substances and complete the table. So we need to complete this table. The first one, substance. The substances are given here. The components present in the substance. Like in air, we have already discussed, air is the substance. Hydrogen, oxygen, argon, carbon dioxide, even nitrogen is there. So here there is nitrogen. Nitrogen. You all know, students, or you would have heard about this. Nitrogen is the highest amount in air. There is high amount of nitrogen in air. About 78% of air is nitrogen. Then only we have oxygen, argon, carbon dioxide and a small amount of hydrogen also. So in this, if we look at the number of components, contains one component only? No, because there are many. So it contains more than one component. That is where we put the T. But if we take pure water, it's only water. So it contains only one component. That is what we have to do there. So in the table, we need to mark whether it's pure one component or more than one component. Take the drinking water. Now again, drinking water, I told you all, it has a taste. It does have an odor. So that means in water, there are various gases dissolved in water. Even chlorine can be dissolved in water. Oxygen, carbon dioxide. So like that, there are various gases dissolved in water. And also there can be salts dissolved in water. Salts like sodium chloride, the salt that we use at home. You all know some of the well water, they have a salty taste. Sea water is salty. So like that, even drinking water can have salts dissolved in it. So water, various gases dissolved in water and salt. So what is it? It contains more than one component. Then the next one, sugar, what we have at home. It's only sugar. Components are only sugar. So that means contains one component only. Salt solution. So when you dissolve salt in water, you get salt solution. What is that? That has salt, that has water. So how many components? 2 components. That means there are more than one components there. So that is again coming under the second column. Then we have the next one, a piece of copper. A piece of copper. A piece of copper, that is only copper. Have you all seen a piece of copper? You would have seen it in the lab, you would have used it in your previous grades. Or if you take the current wire, inside the rubber casing, you would have seen copper. Sometimes you would have seen copper vessels, copper ornaments at home. So that is only copper. When you say a piece of copper, it's only copper. But sometimes it can be mixed with other substances, then we don't call it copper. So if it's only copper, that's only one constituent. So here it's only one component only. Then tea. Tea you all know, we need to take tea leaves, we need to put sugar, sometimes we need milk. So here tea, water, sugar. So then there are more than one components. Aluminium. When we say aluminium, it's only aluminium. So here it is only aluminium. So then how many components? Only one component. Iron. Aluminium you would have seen a whitish color, silvery shiny substance, a metal. So that is aluminium. Aluminium vessels you might have seen, aluminium sheets. Then iron. A lot of things at home are made up of iron. So that also you would have seen a greyish color, shiny metal. So iron, only iron. So that is also one component. Then we have silver, silver jewelry, silver vessels, silver ornaments. So there again silver means only silver components. So they are also one component. So from this chart, from this table, what can you conclude? You can see pure water, sugar, a piece of copper, then aluminium, iron, silver, they all have only one component. So that means they are all pure substances. Pure water, sugar, copper, aluminium, iron and silver. They are all pure substances. Whereas air, then drinking water, salt solution and tea, they are non-pure substances. You have to remember the term, students. Non-pure substances, because we drink tea. So that has more than one component. That is why we call it non-pure substances. But you can drink it, okay? So that's why we have to use the term non-pure substances. I am sure you can understand that now. So then I will move on to the next slide. Based on the components contained, matter can be divided into two main categories as follows. We have discussed that, the pure substances and non-pure substances. So we have pure substances and non-pure substances. So in pure substances, there is only one component. In non-pure substances, there can be two or more components. Is that clear to you all now? Yes. So then I will move on to the next slide. So first we will look at pure substances. We will try to understand what pure substances are. Pure substances, substances having a constant composition, that is, substances containing only one component with definite properties are called pure substances. I will explain that. So the first part, substances having a constant composition. When you say constant composition, now we looked at some examples. We discussed, I will write the examples here. You can remember water, pure water. Then we said sugar. Then there is copper, right? Now, if you take water, water is different from sugar. Water is a liquid. You all know it's a colorless, odorless, tasteless liquid, pure water. Then sugar, you know, sweet taste, it's solid, crystalline in nature, it's somewhat hard, not a smooth texture, hard texture, right? Then you know copper. Copper is a reddish brown color metal, a solid. You have seen copper, right? So it has a shine. Like that, it has definite properties. So water has definite properties, sugar has definite properties, copper has definite properties. So all pure substances, they have a definite property. Why? Because they have a constant composition. Now we will discuss the composition of different substances. Then you will understand the elements that make up different substances. They will be always constant. They will be the same. You take water in our country, water in another country, any part of our country, anywhere, if it is water, it has a fixed composition. If it is sugar, the same composition. Copper is the same. So they have constant composition. That means they contain only one component. So only water molecules or water particles, only sugar particles, only copper particles. So that is only one component with definite properties. That's what I explained to you all. are called pure substances. So can you all understand now? Substances having a constant composition, that is substances containing only one component with definite properties. So only one component with definite properties. So water, only water components, water particles, and they are always liquids. They are tasteless, odorless, colorless. So that is the definite property. If you take copper, always solid, reddish brown in color, they are made up of only copper particles. So definite properties and one component. Is that clear to you all? So then, based on the nature of pure substances, they can be classified into two groups. So here, if we take these three examples, students, if I say copper, copper is made up of only copper particles. So this copper is actually known as an element. Now like this, there are many elements. These elements again have a definite composition. So that means they are made up of only one type of components with definite properties. So copper is an element. But if you take this water and sugar, they are made by the combination of different elements. Now if we take the water, we will discuss this again. Water is made up of hydrogen and oxygen. So that is known as a compound. Whereas sugar is made up of carbon, hydrogen and oxygen. So this carbon, hydrogen, oxygen, they are all elements. These elements can combine and form compounds. So these two are compounds. Elements, compounds. But all these elements and compounds are pure substances because elements are made up of only one type of element, that is the constituent particle, and it has definite properties. And compounds again are made up of the same type of constituent particles, water particles or sugar particles. So they also have definite properties. So both elements and compounds are pure substances. So here, based on the nature of the pure substances, they can be classified into two groups. The two groups are elements and compounds. Is that clear to you all, students? So we had matter. Matter was divided into two groups, pure substances, non-pure substances. Pure substances, they have a constant composition, that is substance containing only one component with definite properties. So under that, they can be either elements or they can be compounds. Now we will try to understand elements and compounds in little bit more detail. First one is elements. So here, elements, pure substances with definite properties which cannot be further divided by physical or chemical methods into substances are known as elements. Again, try to understand. Elements are pure substances. So they have definite properties which cannot be further divided by physical or chemical method into other substances are known as elements. Is that clear? So here, if we try to understand this definition, now element, I told you all, copper is an element. We said copper is an element. Now if you have copper, if you take a solid piece of copper, they are all made up of copper particles. The copper element is made up of copper particles. Now these particles, there's only one type of constituent particles. It has definite properties. Now by physical or chemical methods, what are physical methods? Methods like heating, cooling, trying to press it, compress it, those are all physical methods. By doing that, you cannot change them into other substances. If you change it, then that's not copper anymore. It will become something else. Is that clear to you all? The same way when we say chemical changes, if you burn something, you can mix it with some other chemical. Then also, it won't change into something else. You can't divide it into something else. It will become some other substance. It cannot be divided into other components. Is that clear to you all? So, by applying physical or chemical methods cannot be divided into other components. Okay, you cannot divide them into other components, simple components. But by doing something, you can change them. Like say, if you react copper with something, it will become something else. Or for example, if you have carbon, if you burn carbon, carbon is an element. If you burn carbon, that's a chemical change. There, it will become carbon dioxide. But you cannot divide carbon. You can change carbon into something else. You cannot divide carbon. The same way, you have copper. You cannot divide it into smaller components by other physical or chemical methods. But you can change it. Is that clear to you all, students? So, with that understanding, we will go back. So, here you can see elements. I explained this to you all. So, pure substances, you have to remember this. Pure substances with definite properties which cannot be further divided by physical or chemical methods into substances are known as elements. You all have to remember that explanation. Then, as at now, scientists have identified nearly 120 elements. This is important. There are about 120 elements that have been identified. Now, we have discussed a few before. You can remember iron, copper, aluminium, all those are elements. So, we have come across a few elements. I mentioned carbon. Then, there are some more elements given to you all. You would have seen and learned some of these elements in your previous grades also. So, trying to understand what elements are and try to understand that they have definite properties. Now, we will go to the lab and look at these elements. Okay, students. So, we will now observe some elements here. You all are familiar with pure substances, substances that are made up of one component or one type of component particles with definite properties are known as pure substances. And you all know there are two types of pure substances. One of the type is elements, the other is compounds. So first I am going to show you all some elements that are available in the lab as well as elements that we use in our day-to-day activities. So what are elements? Again, elements are pure substances that have a definite property and that cannot be divided into other substances with different properties by physical or chemical methods. So, these are all examples of elements. There are about 120 elements which have been identified by scientists, but we will be looking at a few. So, here I have the first element, that is sulfur. Here you all can see, students, sulfur is a solid. a powder-like substance, crystalline substance. That's why you can see a shiny nature there, and also it's yellow in color. So those are properties that are definite for sulfur, which you can observe. In addition to that, they have many other properties which are definite properties of that particular element. So if you compare the sulfur with chlorine gas, now here the second element is chlorine. Chlorine is a gas. So this was a solid, this is a gas. Again, different properties. And can you all observe the color? Can you all observe the yellowish green color of chlorine gas? So there again you can see, students, it's a gas, it has a yellowish green color. So that has its definite properties, chlorine gas. Then the third element here is iron. Again iron, here we have it in the powder form, a black color powder. Again there is a shine. If you observe closely, you can see here, students, it has a shine. We use iron at home, that is in the solid form with different structures made from iron. So you all are familiar with what iron is. It's a metal. Then we have copper. Again, copper is a solid substance. It has a reddish brown color, shiny metal. So here you can see the shiny nature of the copper substance or copper element as well. Again, solid and with different properties. So here, students, we have carbon. I have two forms of carbon. You all can see here, this is carbon, a black color substance, and this is also carbon, another form of carbon that is also black in color. Even the pencil lead that we use for writing, that also is made up of carbon. So you all can understand carbon exists in different forms. You will learn these different forms in more detail in your higher grades. But for now, you all can remember this is an element, so that is made up of carbon particles and they have definite properties. Then again I have mercury here. This is a liquid. You can see it has a silvery shine, and this is how mercury moves around. If you had a drop of water there, you all know how water moves around or flows around. That is different from how mercury flows around the petri dish. So that means mercury has its own definite properties. Silvery, shiny, liquid substance. Then we have the next element, that is aluminium. Here you can see, students, aluminium, again they have silvery shine and it is a solid element. So aluminium. And you all know aluminium foils, aluminium metal that we use at home as well. It's available as sheets or foil as well. Here we have zinc. Zinc again is also a shiny solid substance. You can compare the colors and see slight differences there between aluminium and zinc. So from all these observations, students, we are not going into detail about their properties, but from just the observations, you all can understand that all these elements are different from each other. So that means they have their own definite properties. So they are made up of one particular type of particles. If we take sulfur, sulfur particles. Say iron, iron particles. Chlorine, chlorine particles. So likewise, all the elements are made up of one type of particles according to the element, and they have definite properties. So those are the elements that we use in the lab as well as in day-to-day activities. Okay, students. So did you all see all the elements clearly? Did you all observe their properties? I am sure you did. So we were able to look at all these elements. You were able to see this one. This is sulfur. I told you all this is sulfur. A yellow color solid substance. So that is a definite property of sulfur. Then what did we see here? Chlorine gas. It has a greenish yellow color gas. So you can remember seeing that. Chlorine gas. So if you see these again, you should be able to identify them. Then what did you see after that? Can you remember looking at iron? Yes. So you saw iron. Iron, a dark or blackish grey color solid with a shine. Iron has a shine. Then you were able to see copper. It was not exactly a roll like that, but you were able to see tiny pieces of copper metal. So there you were able to see copper. What were the definite properties you all observed? It was a reddish brown color solid. It had a shine. So all those were definite properties of copper. Sulfur, chlorine gas, iron, copper. Then you were able to see carbon. Carbon either exists as a carbon powder like this, or we can have the carbon graphite like a small rock. So that also you were able to observe. Carbon. Again, carbon is a black color solid. That also you were able to see. Then we saw mercury. Mercury, a silvery shiny liquid. That's very important. Silvery shiny liquid. And inside the petri dish, it just moves around. You can remember that. Like small drops like shown here, it kind of moves around. Silvery shiny liquid. Mercury. Then we had aluminium. Aluminium. Aluminium again, a kind of a silvery shiny powder, solid. Then we had zinc. That also silvery shiny solid. So all these, sulfur, chlorine gas, iron, copper, carbon, mercury, aluminium and zinc, all these are pure substances and they are elements. So that means sulfur is made up of sulfur particles only, chlorine gas is made up of chlorine gas only, iron only iron, copper only copper. Like that, all these are made up of only one constituent particles and they have definite properties. So now I am sure you all can understand this. Can you divide them into simple components by physical or chemical methods? No. You cannot divide sulfur further. You cannot divide mercury into smaller components. You cannot divide zinc into smaller particles. So that is what a pure substance element is. So now we are looking at elements. Under pure substance, element. You cannot divide them by physical or chemical methods. Can you all understand that now? I am sure you can. So with that, I will move on to the next slide. So here we discuss compounds, the second type of pure substances. Now I told you all, these elements can combine. Now like English letters, we have A, B, C, D, 26 letters. By combining these 26 letters, we can write so many words. Thousands, actually millions of words. The same way, we have about 120 elements. You can combine these elements, or naturally, these elements have combined and formed many different compounds. Compounds are also pure substances. So that means they are made up of only one type of constituent particles and they have definite properties. So, if we look at compounds, compounds are homogeneous, pure substances in which two or more elements are chemically combined in a fixed ratio. Again, you will have to understand all the terms. Homogeneous. When we say homogeneous, if you take water, water is a compound. I told you all that. If you look at water, if you have a glass of water, water at the bottom of the glass, say at this point, water at this point, water at this point, all are the same. There is no difference. Water on this side, everywhere. Even if you have a very large tank full of water, at every point, water, the composition is the same. That is what we mean by homogeneous. Then there are pure substances that you know because it's only made up of water components and they have definite properties. Liquid, no color, no odor, no taste. So those are all definite properties. In addition to that, they have many properties. These are properties that you already know. So pure substances in which two or more elements are chemically combined in a fixed ratio. So in water, there are two or more elements. So in water, there are only two elements. But if you take the other compounds, there can be three elements or more elements. So two or more elements. In water, there is only hydrogen and oxygen. And this hydrogen and oxygen, there are two hydrogens and one oxygen. That is a ratio. You all know what ratio is, how many of each component is there. So, two elements, hydrogen and oxygen, combine in a fixed ratio, 2:1 ratio, and that is a chemical combination. Once they combine like that, you will get water. It will have definite properties. So, it's a pure substance and it will be homogeneous. So, that is what we mean by compounds. The properties of a compound are different from the properties of the elements that contribute to form that compound. So, this is another thing that you have to remember, students. Now, you know hydrogen gas. Where do we get hydrogen gas or use hydrogen gas? To fill balloons. Hydrogen balloons. The balloons normally go up, you tie it with a string and all that. For decor, we use hydrogen balloons. So again, hydrogen, you know, it's a colorless gas. It's lighter than air. That's why the balloon goes up. Then oxygen. Oxygen is there in air. We inhale oxygen. So that is another gas. Now they too have two different properties. Or hydrogen, the properties of hydrogen is different from the properties of oxygen. Those two are elements. Hydrogen is an element, oxygen is an element. But once they combine chemically in a fixed ratio, the property of the compound is different. Hydrogen and oxygen are gases, whereas water is a liquid. So obviously, the chemical and physical properties of the compound is different from the constituent element. That is what is explained here. The properties of a compound are different from the properties of the elements that contribute to form that compound. So these are the elements that contribute to form the compound and this is the compound. So those properties are different from properties of water. Is that clear to you all? Yes. So then, although there are only 120 elements, there are millions of compounds in existence. So I have told you all this 120 elements like the alphabets, they combine in many different ways forming many different compounds. The reason for this is the possibility of combining elements in a vast multitude of ways with one another. So the reason for this is the possibility of combining elements in a vast multitude of ways with one another. You can combine them in a vast number of ways. You all have to understand that. So with that understanding, students, we will move on to the next slide. So here we have an activity. In this activity, we try to understand how the compound forms from the chemical combination of elements. So activity, inquire into the formation of compounds by the combination of elements chemically. So chemical combination. Required materials are these. We need to have iron. So we need to take iron in a watch glass. You need to observe the properties of iron. We have already seen iron. Then we need to have sulfur. Again, sulfur is a solid, yellow color solid. You have seen that also. Observe the properties of sulfur. Then what we do is we put them together in a crucible. You know what a crucible is. It is a laboratory equipment that is used to heat substances for a long period of time at a high temperature. So we use a crucible. In the crucible, we heat it to a high temperature. Then you will see the formation of the other component. That is going to be iron sulfide. So then you can compare all of them. Now you must be wondering, this is the product of the reaction. After reacting only you are going to get that. Why have I put it under required materials? Because once you get that, you are going to compare the properties of iron sulfide with iron and sulfur, so that you will understand the meaning or definition of compounds. Is that clear to you all, students? So a simple activity, we will go through the method again. Method, observe the iron powder and sulfur powder separately. So iron powder, sulfur powder, you have to observe them separately. You can note down the properties as well. Then mix them together in a crucible. I told you all about crucible. Crucible will be a container like this, or this, or something like that, which you can heat for a very, very long time. A very thick one. So you can heat it for a long time. Heat the mixture, observe the changes. So that will be the change. Then you have to compare that with the two initial elements. These two are elements, that is a compound. So then you will understand how the properties change. So now that you know the steps of the activity, students, we will go to the lab and do this activity. Okay, students. So you all know under pure substances there are two main types, the elements and compounds. Elements are substances with definite properties made up of one type of components, and they cannot be converted by physical or chemical methods into other substances with definite properties. So here we have two elements which we have already observed. Sulfur, a yellow color powder, and iron, black color solid substance. So both are solids, both are in the powder form. This is yellow in color and iron is black in color. What if we mix them together? So I'll just take a small spoonful of iron powder and a spoonful of sulfur powder. If we just mix them together like this, it gets mixed, but still there is sulfur and iron separately. If we transfer this solid mixture, you can see here, students, the solid mixture into a crucible. Now you all know, students, this is a mortar and a pestle which is used to grind or mix substances completely, make it into solid, to grind solids into powder or crush out something. That is the use of a mortar and pestle. Whereas we have crucibles in the lab, we use that to heat substances to a very high temperature over a longer period of time. So if I transfer this mixture into a crucible and heat it for a long time, these two substances, the elements, sulfur and iron, will react or will combine chemically and form iron sulfide. So there it is a chemically combined form of iron and sulfur. That is a compound. So that is what we will do. I will not be showing the procedure. I will show you an iron sulfide substance that has been already prepared. So as I told you, students, after heating, this is how the iron sulfide looks like. You can see, although iron powder is also somewhat black in color, this is also a black color powder like solid. The two colors are different. The reason being sulfur and iron combine chemically to form the compound. So that is iron sulfide. With that, students, I will show you all some examples of compounds that we use in our day-to-day life as well as in the lab. So as you can see here, students, this is copper sulfate. So from the name itself, you all can understand there are more than one elements that are chemically combined in a certain ratio to form copper sulfate. So there are 3 elements actually combined together, which you will discuss in your later grades. You can see the properties here, students. I showed you all copper, I showed you all sulfur. You can remember sulfur is a yellow color solid substance, whereas copper is a brownish or reddish brown color shiny substance. But here you can see, and oxygen is a gas, but here you can see copper sulfate is a blue color crystal-like substance, solid substance. So that again has its own definite properties. So a compound copper sulfate. Then we have sodium chloride. That is something you all use at home also. The common salt or the table salt, that is also sodium chloride. So this is the sodium chloride solid, white color, crystal-like powder. Then we have glucose, again something that's familiar to you. This is more powdery in nature, and you can see that also has a slight shine, and it is a solid substance, white color solid substance. Then we have calcium carbonate, what we call as limestone, that also we use at home as well as in the lab. So this is calcium carbonate, again a white color solid substance. And sodium hydroxide. That is a substance, a solid substance that is used in the laboratory as a common laboratory chemical. Sodium hydroxide, it is usually available as a pellet. Here you can see it is present in the chip form. So a white color solid substance. So these are all different examples of compounds. In addition to that, if we take carbon dioxide, from the name you all know, carbon and oxygen, they combine chemically to form carbon dioxide. That is a gas that is present in the atmosphere, and also we use that in carbon dioxide fire extinguishers. I don't have that here, but that is also a compound. So as you can understand, students, under pure substances there are elements and compounds. You all can understand how compounds form from the chemical combination of elements, and we have looked at some examples of compounds that we use in our day-to-day life as well as in the laboratory. Okay, students. So you all observed the activity clearly? Yes. You were able to see sulfur powder, a yellow color solid substance. You were able to see the iron powder, grayish black color, shiny solid substance, powder-like substance, because we had it in the powder form. Then we mixed it together, and when we heated, what did we get? A black color solid. So the properties, the yellow color solid sulfur, grey color shiny solid iron, when they reacted chemically and combined chemically, you got a black color powder. So all the properties of sulfur, properties of iron are different from the properties of the compound iron sulfide. So now you all can understand that concept. So if I write down the observations, I can say sulfur, yellow colored solid. Then iron, grayish color solid. And when we got iron sulfide, that was a black colored solid. So that is just the color only. They are all solids, only the color is different that we can observe. The same way, their physical properties, all the other physical properties are also different. Not only physical properties, even their chemical properties are different. So from this activity, students, what can we conclude? We can conclude and say that the properties of the constituent elements are different from that of the compound. Is that clear to you all? So here as conclusion we can say the properties of a compound is different from the properties of the constituent elements that contribute to form the compound. So here students, when we use the term constituent itself, that means it is used to make that compound. But here I have elaborated it and said contribute to form the compound. So the properties of a compound is different from the properties of the constituent elements that contribute to form the compound. In the activity, sulfur and iron are the elements that combine to form the compound iron sulfide. So the properties of iron and sulfur are different from the properties of iron sulfide. That is what you need to understand here, students. So here from the activity, we were able to get these observations. The sulfur being a yellow colored solid, iron being a grayish color solid, and iron sulfide was black color solid. So from that we were able to conclude and say the properties of a compound is different from the properties of the constituent elements that contribute to form the compound. This is something you have to remember, students. So with that understanding, I am sure you all have understood up to now. So students, we will move on to the next slide where we try to look at some of the compounds that we use in our day-to-day life. These are some examples. Now first look at the first diagram or the first picture given here. It is a cylinder that is a fire extinguisher filled with carbon dioxide. You have seen this fire extinguisher. You can see here that is how carbon dioxide is written as the chemical formula. Just know that that is the way to represent it. You will be learning this in your higher grades. So when you look at the cylinder, you can identify that. That is carbon dioxide. So when we say carbon dioxide, from the name itself, you all can guess. Carbon dioxide. Di means two. Oxide is similar to oxygen. So from there, you can guess and understand carbon and oxygen combine in a fixed ratio to form carbon dioxide. So from this example, students, if we take carbon and oxygen separately, these two are elements. There is oxygen in air. In atmospheric air, we saw that there is oxygen. Carbon is also used in our day-to-day life. The carbon lead that you have in your pencil, that is carbon. In batteries have carbon. So those are carbon. Carbon is an element, oxygen is an element. But when they combine chemically, when these two chemically combine in a fixed ratio, you get carbon dioxide. Carbon dioxide. So this is a compound. Now we are looking at different compounds. So carbon dioxide is one compound. We have looked at this carbon dioxide. So that is 1. Then we have copper sulfate. Copper sulfate. In copper sulfate, there is copper, there is sulfur, and there is oxygen. Copper, sulfur, and oxygen. That's why copper sulfate. Copper sulfate you would have seen in the lab. You might have even dissolved copper sulfate. You get a nice blue color solution. That's copper sulfate. Then sodium chloride. Sodium and chlorine combine and form sodium chloride. We use sodium chloride at home. The common salt, the salt that we use for cooking, that's sodium chloride. Then we have glucose. Glucose also something that we have at home. We use glucose for what? When you all are doing sports activities or when you are not well, you need to get energy, then you consume a little bit of glucose. You can just put the glucose, the solid into your mouth, it dissolves well, then you get energized. Or you can dissolve glucose in water and drink it. So glucose is a compound. We get that at home also. So you are familiar with carbon dioxide, copper sulfate, sodium chloride, that is the salt that we use at home. Then glucose, again we use glucose at home, even in school. Then we have calcium carbonate. Calcium carbonate. So you know there is calcium, there is carbon, and also there is oxygen. So calcium carbonate. Calcium carbonate is what we call as limestone. You would have seen limestone rocks when you travel around our country. So this is limestone. This is also something familiar to you. This is limestone. This is salt. Then we have sodium hydroxide. That of course you would have seen in the lab. The sodium hydroxide pellets. So that is made up of sodium, hydrogen and oxygen. Sodium hydroxide. So sodium, hydrogen, oxygen. When you all are remembering the elements that make up these compounds, students, try to relate it with the name. Try to have an understanding. Then it's easy for you to remember. So now are you all familiar with these compounds? These are some compounds that we use in our day-to-day activities. Carbon dioxide, then also carbon dioxide you all know it's there in atmosphere. And also you all know plants use carbon dioxide to produce food. You have learned that before also. So you know that. Carbon dioxide. Copper sulfate usually in the lab. Sodium chloride salt we use at home. Glucose we use at home. Like that there is sugar. That also we use at home. Then sodium hydroxide normally in the lab. Calcium carbonate, that is limestone. Sometimes we have it at home. Otherwise we use it in the lab. And limestone, calcium carbonate is used for many other purposes as well. So like this, you can think of many compounds that you use in your day-to-day life. I'm sure you all can understand this clearly. So with that, students, I'm going to move on to the next slide. In this slide, we will look at the elements contained in some compound. So we have looked at these compounds. Now we will try to understand the elements that are present. So we have the compound in the first column. The second column we will try to fill up the elements that are present in that compound. So I have told you all the first compound, we saw that before, the blue color crystal-like solids. That is copper sulfate. In that there is, you can remember, copper, sulfur and oxygen. So here there is copper, sulfur and oxygen. Then what do we have? The second compound, sodium chloride. I told you all to remember the names. Sodium chloride. So it's sodium and chlorine. So there is sodium and chlorine. So sodium and chlorine. Then what do we have? Sodium hydroxide. So again, sodium, hydrogen, oxide, oxygen. Sodium, hydrogen, oxygen. So they have sodium, hydrogen, oxygen. Is that clear? Then we have calcium carbonate. Calcium, carbon, oxygen. Calcium carbonate, calcium, carbon and oxygen. Then we have carbon dioxide. Carbon, oxygen. Carbon dioxide. Carbon and oxygen. Then we have water. You can remember what I told you all, the 2:1 ratio. What are the elements? Hydrogen and oxygen. Yes, hydrogen and oxygen. So are these clear to you all now? Look at the compounds. Copper sulfate. Copper, sulfur, oxygen. And students, when you write the names of compounds and elements, you'll have to write the correct spellings. That's very, very important. Copper, sulfur, oxygen. Then we have sodium chloride, sodium and chlorine. Sodium hydroxide, sodium, hydrogen and oxygen. Then calcium carbonate, calcium, carbon and oxygen. Carbon dioxide, carbon and oxygen. Water, hydrogen and oxygen. So in all these are the elements that make up the compound and they combine chemically in a fixed ratio. The properties of these elements are different from the properties of the compound. So even in the first one, copper is a reddish brown color solid. Sulfur is a yellow color solid. Oxygen is a gas. Whereas copper sulfate you saw in the picture, blue color crystal-like solid. So the properties are different. I'm sure you all can understand what elements and compounds now clearly. So with that understanding, students, I am going to end this chapter. In the next chapter, I will be discussing more physical properties. We will try to understand those physical properties and we will see how we can use those physical properties in our day-to-day life.